We're going to finish putting together the components of the ignition system on the back plate. So we're going to take a look at a coil. And, there's two coils inside. There's a primary winding and a secondary winding. And the black wire is a common ground. The green wire is the other end of the primary winding. And it should have perfect continuity. And if we take a look, I've got practically 0 ohms, half an ohm. And the secondary winding should have anywhere between 3 and 8,000, or 3 to 8 kilo ohms. And take the common ground and the point that goes to the spark plug. And I have 4.5 kilo ohms, which is right in the middle. So that's good. We prepare the installation of the cable using a dielectric silicone. It helps prevent corrosion, keeps water out. So we'll squeeze a healthy glob onto the point. I've already got my boot installed in the wire. And I take the core of the wire, and I put it right on the needle and push it in and put my boot over it. Now I can check my continuity by touching the wire on the other end and then touching the ground and seeing if I still have my 4 kilo ohms. There it is, 4.5 kilo ohms. So I've got a good connection. So I have about 30 inches of cord on this particular coil. This is for the lower cylinder. I have about 21 inches on the other one for the top cylinder. That's because the one for the bottom cylinder wraps halfway around the magneto plate, whereas the one for the top exits almost immediately. So it needs a little bit less. I'll trim them to their final length once I have it installed and I see how much I need before putting the boot on to attach to the spark plug. So these are the capacitors. I don't really have a piece of equipment to really test the capacitors, but they're new, so they should be fine. If I check for continuity, I should see some current flow through, and then it should drop to 0 as it fills. I'm going to see if that works. Yep. So you see there's a bit of current that starts as the capacitor fills and then drop to 0. So we'll begin with the coil for the top cylinder. So I'm connecting the ground wire to the metal core that is in contact with the rest of the mag plate, and that'll be grounded. The other terminal will connect to the points over here, but I'll wait until I also install the capacitor, because it also connects to the same point. what I want to do is snug these down just lightly. I don't have a ring for adjusting the coils, so I have to just make use of feeler gauge or the end of a large screwdriver to position the coils flush. And then check with my finger. That feels good. And we'll check the other one. Just a little bit more. That feels good. Snug those up. And that's the first coil installed. Now we'll put in a capacitor. So we want to have the capacitor and the terminal for the primary coil connected to the point. So I'll give a quick explanation about how the ignition system works. As the magnet travels past these iron rods, they induce a magnetic field. So as the North Pole comes by this becomes south. Then as it travels here, the north, this becomes south, this becomes north. And as it continues, then this becomes south and this becomes north. So this alternating magnetic field induces an electrical current through the primary coil. And that is, and while the magnet is going by, the point is closed, and so there is an electrical current traveling through the primary coil. Now that current has a high amplitude but very low voltage. So there is a secondary coil with multiple more windings, perhaps 20 more windings than the primary coil. Thinner wire, more windings, and what this does is it steps up the voltage and steps down the amperage. Now, that secondary coil is not a closed circuit. It meets a gap at the spark plug. And what happens is that as the electrical field travels through the primary coil, that creates a magnetic field that induces an electrical potential in the secondary coil. It doesn't go anywhere, so it's kind of like pulling back a bowstring, creating an electrical potential ready to take off. And what happens is that when the point opens, the electrical current inside the primary coil collapses. So the magnetic field collapses. It goes from an extreme on one end to nothing. And that lets go of the electrical potential that's built up in the secondary coil. And it rebounds with much greater force than it was able to induce. And that's what creates the voltage necessary to jump the gap and create the spark. So there's an instantaneous, shortly lived electrical current that is so strong that it'll pass the gap on the spark plug. What the capacitor is for is to make sure during all this time that when the point opens, there isn't an electrical spark that jumps that very small gap. So that when the point opens, the electrical current that is flowing gets absorbed into the capacitor instead of jumping the gap at the spark plug. So that's how these three components work. So the two coils, the two windings within the coil, the capacitor, and the points. They all work together to create this short-lived instance of high voltage charge, enough to bridge the gap within the spark plug.